Hello, and welcome to my Physics 2212 Lab 4 report. Today, we will be modeling and observing the behavior of DC and RC circuits. To do so, we will be using a circuit simulator where we can model the behavior of different circuit configurations. We will be applying the principles of charge conservation and the loop rule, as well as knowing the concept of a circuit being in steady state. A circuit that is in steady state has nothing that is changing the current over time. Using the circuit simulator, the circuit shown on screen was created. The voltage of each of the batteries was set to 1.5 volts. We predict that the current at I1 and I2 are equal due to the conservation of charge. Starting the simulation confirms that the current is the same throughout the circuit. Changing the direction of the ammeter does not affect what it reads. If the top ammeter is removed and replaced with a voltmeter, then we see that the circuit is not complete. The potential difference across the gap in the wire is 3 volts, while the ammeter at the bottom reads 0 amps. The wire is then attached to complete the circuit, and the potential difference is calculated across each component. As seen in the graph, the sum of the voltage changes across the entire circuit is 0. This abides by the conservation of charge and the loop rule. Note that using the voltmeter also did not affect the reading of the ammeter, as it was applied in parallel to the circuit, which does not affect the current according to the node rule. We then use the formula resistance is equal to the potential difference divided by the current. This gave us that the resistance of the 47 ohm resistor is closer to 48 ohms, and the resistance of the 100 ohm resistor is closer to 102 ohms. The wire and the ammeter both had resistance of 0. We then created an RC circuit with a 10 ohm light and charged the capacitor until the current stopped flowing. Following that, we removed the battery and started the circuit again, allowing the capacitor to discharge. This caused the current to flow in the opposite direction. It took 15 seconds for the capacitor to discharge with the 10 ohm light. The experiment was then repeated with the 20 ohm light. It took 26 seconds for it to discharge with a 20 ohm light. A circuit was then made with a 9 volt battery, a 30 ohm resistor, and a 200 millifarad capacitor. The capacitor was charged, and then the battery was removed from the circuit. The voltmeter was then used to calculate the initial value of the potential difference across the capacitor, which was 8.68 volts. Over 20 seconds, the graph of time versus the natural log of potential difference divided by the initial potential difference gives the graph shown. This graph was expected to have a slope of approximately -1 over resistance times capacitance. It is approximately that. There are 2 hypothetical questions that need to be answered as well. First, if we did this experiment not in the simulation, the ammeter would have had slightly different readings. The differences in readings would have been due to some resistance in the wires and the ammeter itself. Secondly, we saw that the capacitor changed at the rate laid out in the differential equations in the lab instruction documents. This was expected as the resistance is minimized in the wires and ammeter in the simulation. Thank you for watching.